Okay, this is pre-class notes for section 3.4. Objectives are to learn the definition of a function, domain, and range, evaluate functions, use the vertical line test to determine if a graph is a function, and determine, sorry, that's an extra one left over from the last section. We can mark through that one. I did not catch that that needed to be deleted. So yeah, just 3 objectives. A function is essentially an equation. It's the same thing as an equation, except it has a special parameter that general equations don't. It says that each, and I'm going to reread this in my own words because I don't really like the way that the book describes it, so we're just going to write our own little Metzger's definition of a function. So each x value, sorry, that looks like an x. Each x can only be used once with a specific y. So they state it a little differently. It makes you think that you're focusing on y. You're actually focusing on x's not repeating. So for example, if you had the ordered pairs 2, 1, 3, 2, and 4, 1, each x is unique. That means that this would make a function. But if I had 2, 1, 3, 2, and 2, 3, notice this group has repeated the same x with 2 different y's. So that would be not a function. Okay. The domain is just the x values of the function. The range is the y values, or the things that we get when we evaluate or plug in. And this is just a picture showing you that this is a domain and this is kind of our range over here, and we're showing you how elements from this set get mapped onto elements or function images over here. Okay. And then again, these are not really going to help you much for 136, but if you go on to calculus or something, you might see a function described like this. A set with a function on it gives you another set, or a function from D to E, or they may even just use the circles. We won't do really much with that at all. We're going to mainly focus on evaluating and then telling some things about graphs of functions. So if 2 functions are equal to each other, you can write this. Oops. I don't know why that keeps jumping. So if 2 functions are equal to each other, we can just write f of x equals g of x. There's a lot of things here you can read. An implied domain, we already talked about this in the last pre-notes. If you have a square root involved, then that means that you have to keep our numbers real, not imaginary. So we have to keep that inside of that radical, remember, greater than or equal to 0, so it doesn't have a square root of a negative number. Also, things that are implied, if you have x's in your denominator, that means that you cannot have a value for that, because you would say, if I divide it by 0, I would have an undefined function there, so we don't do that. So anything that causes imaginary numbers or dividing by 0, they're not part of our domain. Okay, so let's just start with a basic example. Here is a function. And f of x is really the letter y, so don't let that freak you out. It's not f times x. This is read f of x. So what is y if I plug in x? That's essentially what they're saying. So we're doing f of negative 3, which, be careful here, this is a negative and then the x spot cubed. So negative negative 3 cubed minus negative 3 squared plus 3. You don't do anything to this. This is just our notation. You work out the right side. Negative 3 cubed is negative 27. Negative 3 squared is 9. So that would be negative negative, so that's positive 27 minus 9 plus 3. 27 minus 9 would be 18, plus 3 would be 21. Let's do f of 0. Negative 0 cubed minus 0 squared plus 3. 0 times anything is 0, even if you times it by the negative 1 out front. Another 0 and plus 3. So this would just be 3. And then f of 2. negative 2 cubed minus 2 squared plus 3. That would be negative times an 8. So that's negative 8. That's 4 when you square it, but then there's the negative. So that's negative 12 plus 3, or negative 9. Okay, so there's our first example. This one is a little bit different. Notice that there's an implied domain here, or restricted. I like to use the word restricted, but our book uses implied. X cannot equal 3, or you will have a 0 in your denominator, which means I cannot evaluate this guy right here. This one is going to be undefined because they're asking you to plug in something that doesn't work. So we only have to do the other two. Again, focus on the right side. This would be negative 2 over negative 5. And if we reduce that, that would just be positive 2/5. F of 0 is 0 over 0 minus 3. That is 0 over negative 3. And 0 on top is just 0. Okay, this next piece, this is having us do some different evaluations with variables. So they're asking us to, instead of plugging in a number, they're saying plug in A. Okay, so for this first part, f of A means just change the x's to a's. That's all you're doing. So 3 minus 4a. B part says do f of negative a. So we write our function again. We write 3 minus 4 times negative a. So that would be 3 plus 4a. Here's my first answer. Here's my second answer. This is different. This says do negative 1 times the function evaluated at a. Okay, so negative 1 times f of a would be negative 1 parentheses, and we already know what f of a is. It's 3 minus 4a. That was a part. So if we distribute that negative, that would be negative 3 plus 4a. For D, we're doing a plus h inside. So that's a binomial getting plugged in where there used to only be one thing. So we will probably have to do FOIL or distributive property when those things happen. It looks like we have to distribute. So this is 3 minus 4a minus 4h. No like terms, so that would be my final answer. This one's a little different. E says do f of a, then f plus f of h. Do those as two separate things. F of a, we already know, was 3 minus 4a, so that one's there. Plus, f of h is the same thing, but you make this an h instead of an a. If we add those two polynomials together, you get 6 minus 4a minus 4h. So note, there's a general thing we have to worry about here. You can't just say because you're adding something inside, you can split it up and add it outside. It did not equal the same thing. One of them had a 3, one of them had a 6. So they're not the same. And then this last one I left room over here to do. This is a little tricky. This says f of a plus h, which we've already done, which was part D, minus f of a, which was part C, because that's negative 1 times f of a, all over h. So we've already done the pieces of this when we did C and D, because that's kind of our numerator there, but we have to put it all over h. So 3 minus 4a minus 4h, and then we pull down the negative f of a. That was negative 3 plus 4a all over h. So then if we combine some like terms, our 3's are going to cancel. Negative 4a cancels with 4a. So it's just negative 4h over h. So that just comes out as negative 4. This is going to have a special name. We're going to do a lot of these in class, so don't think this is the only time you're going to see it. This guy right here will come up on the test for sure. So I'll do a bunch of these in class. Okay, if you have a graph, you can talk about the function. You can talk about when it's increasing, when it's decreasing, and when it is constant. Note that this is flat. So we can talk about lots of different things, and this is just an application problem, just showing you what a function can look like. What we care about is if you have a graph in front of you, how do you know it actually is a function? Because not all graphs or equations are functions. So that's where we come into something called the vertical line test. The vertical line test says, If you draw vertical lines across your graph, as long as you touch the graph only once per vertical line, so I'm just imagining some kind of graph here. As long as your graph only touches each vertical line once, then you are a function. So it says in at most 1 point. If you touch it more than once, then you are not a function. So for example, this first one is not a function because it touches that vertical line that I picked right there twice. And it doesn't matter. If it fails one vertical line, it fails the whole test. This one also fails the whole test because any vertical line I pick between here and here is going to cut that circle twice. Let's look at our next two, and these will be our last two. This one's good. You could pretty much imagine drawing vertical lines all the way across this graph. And yes, I know this looks like, well, this kind of looks like it gets straight, but this keeps getting wider. So this one, yes, is a function. It passes the vertical line test. So this, whatever equation would be tied to this graph, is a function. This one's tricky for students sometimes too because they see the chunks. As long as one of them is open and the other one is closed where they overlap, or they could both be open, that means that you're not using that point twice. You're actually saying it's empty there. Again, this one's okay because it's open and this is closed, and it passes the vertical line test always between. So this one actually is a yes. It is a function. So these last two are both functions. Okay, we'll be talking a lot more about 3.4. There's a lot more to do in this section in class time. So just make sure that you've watched all your pre-videos.